In exercise 2231, we want to take a look at some data from two populations again. And here we're looking at the raw data. We're going to want to download this number MM by gender Excel file. So here a study investigated how many M&Ms were taken by a sample of 20 college students who were presented with candies in a 24-ounce bowl. Let's compare the numbers of M&Ms taken by males and females, and we're going to investigate whether one gender tends to take more candies than the other. So let's go ahead and we're going to download that file, and we'll do a 99.9% confidence interval for mu female minus mu male. So in our Guru, going to import that data. It should be in my downloads. Okay, I think I actually already downloaded it or uploaded it here. So we'll call it number MM by gender 1. All right, now we're going to go into analytics to mean inference 1 and 2 population. And again, I'll be selecting that raw data set. Now I want to go back just a minute and look at that data. If we look at the data, it's a little bit different than the other data set that we had, in that it doesn't have like a whole separate column for the males and a whole separate column for the females. It's all kind of listed in one. So in this case, what I need to do is mean inference. After I select my data, I'm going to go ahead and click on the second option, and I'll take the variable to be number of M&Ms by factor gender. And then down here in the summary, I'll take the two levels to be female and male. And then they do the calculation of the mean and standard deviation for us, right? Notice these sample sizes are quite small. They're 20 each or 10 each for a total of 20. So now when I go to population 1 minus 2, and I look at my test of hypothesis, I think our significance level was 0.001. And going back, I need to look at what we're doing. We're just going to see if there's a difference in the population mean. So I'm not sure if it's going to tend one way or the other. So I'll just say that the alternative hypothesis is that mu1 minus mu2 is not equal to 0. All right, let's take a look at what we've got. My observed t-stat is 0.96. And, I didn't read closely. I'm not doing a hypothesis test. I'm looking at a confidence interval. Let me go back. Basics. I'm going to confidence interval. I'm looking for a 99.9% confidence interval using the t-statistic method. Okay. So now all the way here at the bottom, negative 40.157 to 66.357. All right, we need answers rounded to 2 places. So negative 40.16 to 66.36. There we go. So what does that mean? We are 99.9% confident that the population mean and number of M&Ms taken by females from such a bowl will be between 40.16 less and 66.36 more than the mean of number of M&Ms that would be taken by males. Okay, so now we have to think is or is not here. Without conducting a significance test, because of the duality of inference procedures, we know then that when a 2-sample t-test is conducted to test whether males and females differ with regard to how many M&Ms they take from a 24-ounce bowl, the null hypothesis is not. We are failing to reject the null hypothesis at the alpha equals. So since this was a 99.9% confidence interval, alpha would be 0.001, right? They add up to 1. because the value of 0 difference is within that confidence interval estimate for the amount of difference. All right, so now we're going to go through and check all these things. We have to check to see what were the technical conditions. So of course, we need a random sample. Let's go back up and see if we have a random sample. A sample of 20 college students, but it doesn't say a random sample. So unfortunately, we don't know that the samples were randomly selected. Also, the sample sizes are not large enough, right? They're 10 each. Sample sizes are too small. If the sample sizes are too small, we should go and check to see if our data is normal or not. So here's what we're going to do. We're going to go back to basics. Remember that normal probability plot? We can go ahead and take a look at that. So all the way down at the bottom here, you're going to see the normal probability plot for the female data and the normal probability plot here for the male data. So yeah, those two are within those bounds of being normal. So I would, according to the normal probability plot that we're looking at, graphs of the data appear to be normally distributed. So overall, because the samples are not randomly selected, but and because the sample sizes are too small, but the data does appear to be approximately normal, we still cannot say that this is a valid procedure, because you have to have both that the sample's randomly selected and one of these two things in order to do that. So no, overall those technical conditions are not satisfied. All right, so I hope that this helps using our Guru to work with the raw data.